Okay, so let's look at angular velocity and linear velocity. So angular velocity, the variable that we are going to use to stand for angular velocity is this omega, which is kind of a almost italics looking W. It is a Greek letter, lowercase Greek letter, and it's going to stand for angular velocity. And what we're talking about when we are looking at angular velocity is how fast is the angle changing? At what rate is the angle changing? So this is a rotational velocity. How quickly are we moving through however many whatever measure of angle? So the way we are going to calculate omega is we are going to take the number of revolutions, that's how many rotations it makes in any given unit of time. They'll tell us what that unit of time is. And then we multiply using dimensional analysis by a form of 1. There are 2 pi radians in 1 revolution. So these are radians per 1 revolution. And I have revolution unit of measure divides out. And what I am left with is radians, 2 pi times however many revolutions it was. But what we are left with is radians per unit of time. So that is an angle. How many angles are we rotating through over a given period of time? So radians per time, just like miles per hour is a linear velocity, radians per unit of measure or unit of time would be an angular velocity. Okay. So I have a tire that has a 15-inch diameter on a car, and this tire is making 9.3 revolutions every second. 9.3 revolutions per second. If you look up at my omega, my angular velocity calculation, the linear is not needed. We don't need this information. It doesn't matter how large the diameter or the radius is of that tire. That's not going to affect how quickly it is rotating. So we don't need the linear measure for angular velocity. But you will often be given information about the tire, so it's important to recognize what information do we need and what information do we not need. Well, we do need to know how many revolutions it's making per unit of time. So I have number of revolutions per second. So if I want to find the angular speed or the angular velocity of the tire in radians per second, then I'm going to say omega is equal to the number of revolutions, that is 9.3 revolutions per 1 second. And then using dimensional analysis, I want to be in radians per second. So I know that I will rotate through 2 pi radians per 1 revolution. And again, my revolutions unit of measure divides out. And what I am left with is 2 times 9.3, which gives me 18.6 pi. Don't forget the pi. I had 2 pi radians per second. So my unit of measure is radians per second. Now that is the exact angular velocity, but we don't really know what that means because the pi is in there. So what we're going to do is we're going to approximate it. And that approximation is going to be when I take 18.6 and multiply it by pi, I am going to get approximately 58.433 or 58.434 radians per second, depending on if you round or truncate. I think that I have a larger number of truncators, so I will 58.433 radians per second. So it's rotating through 58, a little over 58 radians every second. So you try this one. We have a 12-inch diameter vinyl LP. It's an album. It makes 33 1/3 revolutions per second. We want to find the angular speed or the angular velocity of this LP in radians per minute. So we want radians per minute. So you can pause the video and go ahead and try to figure this one out. So my angular velocity is going to be 33 1/3. I'm going to want that as a fraction. So I have 100 thirds revolutions per 1 minute. Or I could have said that that was 100 revolutions every 3 minutes. If you don't like the fraction there. But for this, it doesn't matter. So I have my revolutions per minute, and now I need to multiply by 2 pi radians per 1 revolution. So my revolutions divide out, and what I end up with is multiply across the top, I get 200 pi, multiply across the bottom, 3 times 1. 200 thirds pi radians per minute, or 200 pi over 3, or 200 thirds pi radians. I can write it that way, or I can write it this way, times the pi radians per minute. And again, I don't know what that is because it is only it's the exact answer, but with the pi in there, we don't know, we don't have a good feel for how much that is. So if I take 200 times pi and divide by 3, I get approximately 209.4395. The last one I truncated, this one I'm going to round. So that is approximately 209.440. Because I rounded to 3 decimal places, I have to put the 0 in that third decimal place if it makes it round up. And this is radians per minute. Hopefully you got that right. So that is how quickly or how fast is something rotating through angles per unit of time. What about linear velocity? So linear velocity is how fast a point on the circumference is traveling. Okay, how fast a point on the circumference is traveling. And this is going to be a linear distance. How much space is it, or how much linear distance is it crossing per unit of time? So we're going to take number of revolutions per unit of time times 2 pi radians per 1 revolution. And dimensional analysis, the revolutions divide out. Now, this one is a little bit of a stretch for some kids, but because the definition of a radian is the angle that marks off an arc length that equals the radian and the radius divide each other out, because that length of the arc that is marked off by that angle is equal to a radius. So those reduce that also. And what I'm left with now is a linear unit per unit of time. So this gives me linear unit per unit of time. And that is a linear velocity. Now, you're probably going, well, this we just calculated. Number of revolutions per unit of time times 2 pi radians divided by 1 revolution is just omega. So linear velocity is just angular velocity times the radius. This is the linear unit per radius. I'm not dividing out the radius length. I'm dividing out the radius unit of measure. So I have, because it's a linear unit of measure for the radius. So I can also find my linear velocity by taking my angular velocity and multiplying by the radius. Now, I like to set up the entire calculation and not find angular velocity first. But if I had already found the angular velocity, I would not need to recalculate it when I am finding linear velocity. So here's the same problem again, only this time we are going to need the length of the diameter to be able to find our linear velocity. So again, I have this 15-inch diameter tire on a car and it's making 9.3 revolutions per second. Now I want to find the linear speed in miles per hour. So my linear speed, or my velocity, is going to be my angular velocity, which I already found. So I could go back and just use that and then convert with radius. But sometimes you're going to be asked to find linear velocity and not have been given, or asked to find angular velocity. So I'm going to show you how to just from the problem calculate the linear speed or the linear velocity. So I have my number of revolutions, 9.3 revolutions per 1 second, times my 2 pi radians per 1 revolution. And that gets me my angular velocity. And now I have my diameter. I've been told the diameter, but I need to multiply by a unit of measure times the radius. And my radius is going to be in inches. So I'm going to have, actually, I should do this in purple. The radius is in inches, and I should actually put my seconds. I'm going to do that one in a different color. Let's do that one in green, just so that I can see the conversion from my linear units and my time units. So the radius is not 15. The diameter is 15. So if the diameter is 15, my radius is going to be half of 15, or 7.5. So my radius is going to be 7.5 inches per 1 radius. And as I'm going along, I can keep track of, do I have the correct units of measure? So my revolutions divide out, my radians divide out. Right now I'm in inches per second, and I want to be in miles per hour. So I don't care which one we choose, but you're going to convert one of them until you get it to where you want it, and then convert the other. So I'm just going to start by converting seconds. So I need seconds I need to undo from the denominator. So that means I need seconds in the numerator, and I'm going to convert to minutes. I'm going to go from seconds to minutes and then minutes to hours. I actually could, I'm taking up too much space. I actually could go straight from seconds to hours, but there are 60 seconds in 1 minute. So now if I'm keeping track, I am now in inches per minute. So I'm going to now convert, I want to be per hour. That's what I want. So now I need minutes. I need to undo the minutes in the denominator, and I need to introduce hours in the denominator. So I have 60 minutes per 1 hour. So there I have now minutes reduce. I am now in hours, which is what I want. Now I need to be in miles, and I am in inches. So inches was in my numerator. So I need to divide out the inches, and then I'm going to go through feet. So I have 12 inches in 1 foot, and I am now in feet per hour. So to convert to miles per hour, I need to convert feet to miles. I don't know if you know this number, but this is one that you probably should have memorized. There are 5,280 feet in 1 mile. So when I reduce feet, I am now in miles per hour. So that is my calculation for velocity. So now what I'm going to do is I want the exact. So I am not going to type pi, but I need to remember that it's still part of the answer. So I am going to take 9.3 and I'm going to group my numerator. I'm going to multiply across the top. I had 9.3 times 2. I'm not going to multiply the pi, times 7.5 for the radius, times 60. 60 for that was seconds, and then times 60 for the minutes, and then that was times 1 times 1. So that is across the top for my numerator, and then I'm going to do across the bottom for my denominator. So I have 1 second times 1 revolution times 1 radian times 1 per minute times 1 per hour times 12 inches in 1 foot times 5,280. And then if I hit the math button, that first option is frac. What my calculator will do is it will write that answer as a fraction if possible. So my exact velocity is going to be 1,395 over 176. Did I remember that correct? Yes. Pi. I can't forget the pi. Miles per hour. That is the exact miles per hour that I was traveling, or that this car was traveling. So now, practically, I have no idea how fast that is. If a police officer was to pull me over and say, "Pardon me, Mrs. Burleson, do you know how fast you were going?" And I was to say, "Well, of course, officer, I do. I was going 1,395 over 176 times pi miles per hour." The officer would just laugh at me like, "We don't know how fast you were going. You don't know. That is exact, but we don't have any kind of a practical." So what I'm going to do is I'm going to take my answer and I'm going to multiply it by pi, so that now I can see my approximate speed is, I am going approximately 24.90. I am going to round to 1 miles per hour. So if you would like to try this last one, go ahead and pause your video and attempt to find in miles per hour how fast a, oops, I wonder how that got in there. That's funny. Oh, there we go. Miles per hour. find the linear speed of an object on the circumference, it should say. So this should say on the circumference. Okay. So my linear velocity is going to be my 100 revolutions per 3 second or 3 minutes. That's the other way I said you could have done that. 100 thirds revolutions per minute means 100 revolutions per every 3 minutes. And then I have times 2 pi radians per 1 revolution. And now I want to convert this to miles per hour. Well, the radius is 6 inches, because if the diameter is 12 inches, the radius is 6 inches. So I have 6 inches per 1 radius. So I am now in revolutions reduce, radians reduce. I am in inches per minute. I'm going to do the same conversion in the same order as I did last time. So converting minutes to hours, I have minutes in the denominator. So I need minutes in the numerator and hours in the denominator. I have 60 minutes per 1 hour. So I am now in inches per hour. So now let's convert inches. So inches is in the numerator. So I need to divide out inches per foot. So I have 12 inches per 1 foot. I am now in feet per hour. I want to be in miles per hour. So I need to divide out feet and convert to miles. So it is 1 mile is 5,280 feet. And if I reduce, I am now in miles per hour. That is my units of measure that are left. So then when I type this into the calculator and get an exact, you should have gotten 22 over 66 pi miles per hour. And then when you typed that into the calculator, you should have gotten 1.1899. I think I truncated miles per hour. So if you have a spot on the outside on edge of your LP record rotating, revolving at 33 and a third revolutions per minute, that spot on the outside of your LP is traveling at approximately 1.18 miles per hour.